Virtual machine weaknesses now. Under most circumstances, it's safe to assume that the virtual machines are isolated from each other, that the host is separated from the guest and the guest is separated from the host. But the configuration, settings, and vulnerabilities within the hypervisor and the VM tools and other locations can weaken that isolation. Let's talk through some of the potential weaknesses of using virtual machines. And virtual machines and sandboxes are kind of synonyms for each other. So when we say sandbox, when we say virtual machine, they are very similar devices. Virtual machines and sandboxes are based on the same principles. So if we have a host and a guest, if the host is compromised, then it's possible that the guest could be compromised. For example, a simple remote access tool running on the host would only need to take a screenshot to watch the activity of the guest virtual machine or run a keylogger, which would effectively break the isolation between them completely. Maintaining the security of the host operating system is of paramount importance, highlighting the need for a separate secure laptop for high-stakes situations where you're considering using virtualization as your isolation and compartmentalization security control. Also, vice versa to what we've just discussed, a guest VM could compromise the host operating system or other VMs due to vulnerabilities and configuration settings. The hypervisor, sandbox, or the VM tools installed can have security vulnerabilities that could compromise this isolation. One such example of a previous hypervisor vulnerability is Venom, which you can see a diagram here in front of you. For vulnerable hypervisors, it allowed an attacker to escape from the confines of a vulnerable virtual machine guest, which we call a virtual machine escape, and potentially obtain code execution access to the host. This has been patched now by all the major vendors, but obviously if you're using an old unpatched hypervisor, you may even still be vulnerable to this. Here you can see previous virtual machine hypervisor vulnerabilities that have occurred over the years, 2007 through to 2014, 2015. I'm sure there'll be more to come. So that's vulnerabilities within the hypervisor. Here's an example of the virtual machine tools having vulnerabilities. In VMware, this allowed a standard user to escalate privileges to an admin or root user within the confines of the guest. No virtual machine escape in this case, but it's an example of VMware tool vulnerabilities. As you can see, vulnerabilities can and do exist with virtual machines. Virtual machines can leak information. So, for example, traces of your virtual machine's session could be left on the local hard drive of the host, even if it's a live operating system. For example, host operating systems usually use virtual memory called swapping or paging, which copies parts of the RAM to the hard drive. This could contain information about the guest's session, and it could be left on the host's hard drive. So it's potential to get leakage from your virtual machine. Let's think about active attacks now and malware. VMs are used by security researchers to deliberately isolate malware so that the malware can be forensically examined and reverse engineered in order to understand how the malware works. Because of this, advanced malware writers have designed countermeasures that can detect when their malware is running on a virtual system in an attempt to prevent that very same reverse engineering. The more sophisticated malware examines the memory, the file system, the registry, running processes for virtual machine environment artifacts, and looks for VM-specific virtual hardware and processor instructions. It's relatively trivial to detect if you are running in a virtual machine. In some cases, detection of a virtual environment causes the malware to shut down its malicious functionality so that it cannot be properly analyzed in the virtual environment. This is a defense mechanism for the malware. This is great for us when using VMs for isolation and as a security control, as the malware effectively disables itself. It sometimes even deletes itself to help prevent forensic examination. It uses this form of defense because it is better for the malware to not be reverse engineered because it can give it a longer life. So it's good that malware disables itself, but it's not all good news. Some malware uses the virtual machine detection to then attempt to exploit security holes in the VM software, like the Venom example that we've just seen, attempting to perform virtual machine escapes. This wouldn't be good. But fortunately, hypervisor, VM tool vulnerabilities and other vulnerabilities haven't been too prevalent. So mostly the malware will either keep running and not be able to escape the isolation or simply disable itself. Shared networks are also an attack vector. If the guests and hosts share the same network, if any of those machines are compromised, the other machines could be targets for attack. Not technically escaping the virtual machine, but just simply by performing network attacks on the other machines that are part of the same network. In most instances, if you're using VirtualBox on your laptop, the host and guest will share the same network. So for example, maybe you have a Debian host and a Windows guest, which have a bridged network adapter. Windows, the guest is compromised. The Windows VM then attempts an SSL stripping attack on all the other machines on the network to steal the passwords. Even though you have isolation between the Windows guest and the Debian host, and the isolation at the operating system level isn't compromised, at the network level there is an interface, and that interface can be used as an attack vector. VM hosts and guests obviously share CPUs. This means it's theoretically possible to perform what is called covert timing channel attacks. This is the passing of information in which one process signals information to another process by modulating its own use of system resources. For example, central processing unit time in such a way that this manipulation affects the real response time observed by the second process. This means guest and host can communicate via timing variations based on prearranged methods. A timing channel is one example of a covert channel. Again on CPUs, because the CPU is shared, it may be possible to perform side channel attacks to, for example, extract decryption keys from the guests or the host. There's a paper here on this very same thing. And in a lab, the researchers were able to do that under the right conditions using El-Gamal. Features like shared folders, clipboard access, and drag and drop functionality all reduce the isolation and allow attack vectors. Anything you allow the guest to access for convenience is a trade-off with security. The guest can then possibly view your files and copy and paste the contents of the clipboard. If within your VM you have configured them to be accessible, hardware and hardware emulation could be used to breach the isolation. So I'm talking about hardware like the microphone, the webcam, 3D acceleration, serial port, floppy drive, CD drive, USB port, and so on. These could be manipulated and used as an attack vector. There's also a possibility that a bug could be found in the underlying technology that is used by a hypervisor, such as the Intel VTD, and I'm aware of one such example, which is this. This is a complex attack that was able to bypass Intel's VTD imposed protection. Intel VTD, if you're not aware, enables hardware support for isolation and virtualization, and a vulnerability was found by these two researchers here at Invisible Labs. So there was no vulnerabilities in the hypervisors themselves, but in the underlying technology. And when there is problems in the underlying hardware technology, you can't just patch it. And then when we start to think about who needs serious security, privacy, and anonymity, Running a number of virtual machines requires a fast machine with good CPU and memory. Many of the people who need security, privacy, and anonymity are unfortunately not rich. They live in places where there isn't a lot of money and they can't afford a machine to support virtual machines. This is a disadvantage, a major disadvantage of virtual machines for people with limited funds. Virtual machines shouldn't be relied upon as your sole means of protection. It is one layer of a defense in-depth approach. All of the other security controls detailed throughout the course should be applied as well, where appropriate, based on your threat model, your risk, your adversaries, and the consequences, including hardening the virtual machine, which we will cover next. So virtual machines and sandboxes are not perfect, but when configured correctly, they are a very, very effective security control that I highly recommend that you use.